Okay, today we shall be developing arch in main model, or we can also call it GARCH-M model, right? That we shall be developing today. Arch in main model or GARCH-M model. Okay, that we shall be developing today, and we have few variables such as here are the variables, that is BBR. What is BBR? Bangladesh bond return. Then BSR, Bangladesh stock return. Then IBR, what is it? Indian bond return. Then PBR, Pakistan bond return. So what I can do, I can make it zoom. As a result, you can see all variable. So I make it zoom. So these are the variables, you can see, right? So the first one is the BBR, that is Bangladesh bond return. Second one is the BSR, that is Bangladesh stock return. Then IBR, that is called Indian bond return. Then PBR, that is Pakistan bond return. So here I have 4 variables in total, and I assume that all the variables are in stationary, meaning that all these 4 variables have no unit root. Then what happens? So I am telling again, as I said, I have 4 variables such as BBR, that is Bangladesh bond return. Then BSR, that is Bangladesh stock return. Then IBR, that is Indian bond return. Then PBR, that is Pakistan bond return. And here I assume that all the variables are stationary, right? And we need stationary data. We need stationary data to run GARCH-M model. We need stationary data to run GARCH-M model, right? That is the plan. Okay. So here are the data. You can see all the data. I put it like that. I make it block. I open it as a group, right? So you can see all the data here. I'm sorry, I make it big. Okay. So you can see all data, BBR, BSR, IBR, and PBR, right? That is the data we have. Time series data. We have the time series data, and our sample size is something like this. Our sample size is come up here. Our sample size is 200. Then what happens? 200 means 200 days. 200 days of data. That is our sample size. Meaning that until here until I'm coming up until here 200 days. That is our sample size. So here sample size is 200 days, right? So these are all return data, return data, right? 200 days, right? Return data, and here IBR is the dependent variable. What is called IBR? Suppose it is Indian bond return, right? That is the dependent variable, Indian bond return. Okay, and here we shall be developing GARCH-M model. Okay, that means what are the factors? What is the objective? What are the factors affecting Indian bond return? That is our objective. What are the factors affecting Indian bond return? So that is the main objective. So meaning that IBR is our dependent variable. Okay, so now gradually we can develop the GARCH and ARCH model, but there is one condition before running the ARCH model. So so there must have some condition before running the ARCH model. Okay, and if we can fulfill the condition, then only we can run ARCH model. Otherwise not. Condition must be fulfilled. Okay, so what is that condition? The condition is something like that. Number one condition is that there should be number one condition is there should be, okay, conditions. Number one, there should be clustering volatility. That is the condition number one. And the condition number two, ARCH test should be rejected, right? So if there is a two things, then only we can run the ARCH model. That means ARCH test should be rejected, meaning that there should be ARCH effect, and only then we can run the ARCH model. Okay, so I'm saying that there should be two conditions. Number one is clustering volatility, and number two, ARCH test should be rejected, meaning that there should be ARCH effect. Only then we can run the ARCH model. And we have assumed that all the variables that we are using are stationary. And if the variables are not stationary, we have to convert them to stationary, and after that we can run the ARCH model. Okay, so what are the steps involved? The first we check whether there is a clustering volatility or not, and whether there is arch effect or not. Okay, how to do that? First we run the regression model where IBR is the dependent variable, then C is the constant, and PBR is the independent variable. So what is IBR? Indian bond return. And what is PBR? Pakistan bond return. Okay, first we run this model. Okay, so what I do, I run this regression model. So how to run the model? I go to quick, then estimate equation. So I put first IBR, that is dependent variable, then C constant, then I put PBR, Pakistan bond return, and here our sample size that I want to take is sample size is sample size I should take around I'm sorry, I've done a mistake. Sample size should be, last time I said how much? Last time I said 200. No, actually sample size we shall take 300. So here I have done a mistake. So should be 300, not 200, meaning that better. Okay, what I do? So better I show you the data, then we run the model. Okay, that's 300 means just start from here, sample size 1 to 300 days. I'm going down until 300 days. So it is something like this. I'm going. Okay, did I? Yes, I have come to 300 days, right? That means until this. So sample size is not 200. Last time I did mistake. It should be actually 300 days is here. So 300 days sample size is actually 300 days, right? 300 days return, right, of BBR, BSR, IBR, and PBR. Okay, now we run the model IBR, C, and PBR. We run the models, then we check what happens. Okay, we run the model, right? So this is our sample size, right? We run the models. Okay, just 1 minute. We run the model. So how to run the model? I go to quick, estimate equation. So IBR is the dependent variable, then constant, and PBR. What is called PBR? Pakistan bond return, right? So we have this two variable, and so but here I can make it zoom for you. I just make it zoom the whole things so that you can see better. I'm making it okay, and the sample size is 300. I put here 300, right? And I make the whole thing zoom so that you can see better. You can see from here, right? So here IBR, C and PBR, and sample size is 300, and we shall run this regression model to check whether there is clustering volatility or not, or and whether there is a arch effect or not. That we want to check. Okay, so we run this model, right? Regression model. This is our model, and this is our sample size. We run it. Okay, this is the outcome of the all results, right? This is the outcome. And now the question is that, okay, how much is the, and here IBR is the dependent variable and PBR is the independent variable, and we check the residual from it. What is the residual? Residual we can get from here. I click on the receipt, so the residual has come up, right? This is the residuals for 300 days. You can see this is residual, and it is this color. It is residual, right? Residual for 300 days, right? Residual for 300 days. Because our sample size is 300, so residual is also 300 days. Okay, here, okay, first we check whether there is clustering volatility or not. What does mean by clustering volatility? Clustering volatility means that is what is happening. Periods of low volatility are followed by periods of low volatility for a long period, and periods of high volatility will be followed by periods of high volatility for a long period. And when this thing will happen, we can say that there is clustering volatility. And if there is a clustering volatility, then we have all the permission, we have all the validity to run the ARCH model. Okay, we can check from here. Suppose this is day 1, right, until day around 40. So here you can see small volatility, low volatility is followed by another low volatility for almost I can say 35 days, right, until this, from here to here, almost 35 days. And also again from 35 days to until, suppose this one, all the period from here to here, what is happening? High volatility is followed by another high volatility for a long period. Okay, again from here to here, you can see from here to here, that means from 100 days until 150 days, low volatility is followed by another low volatility. Again from 150 days until 250 days, right? I'm saying again, from 150 days until 250 days, high volatility is followed by another high volatility. Again, from 250 days until 300 days, from here to here, low volatility is followed by another low volatility for a prolonged period. So from this one, we can see that high volatility of return is followed by another high volatility of return for a prolonged period. At the same time, low volatility of return is followed by another low volatility for a prolonged period, meaning that in this model there is clustering volatility. So we can run the GARCH model. Okay, the whole thing we can check again by using GARCH test, that whether there is volatility, whether there is GARCH effect have not or not. So we can check GARCH effect now. GARCH effect, how to test it? We can do GARCH test to check whether there is a GARCH effect or not. Okay, how to test it? I go to view, I go to residual diagnostic, then I check the heteroscedasticity test, right? I click here, then I choose the arch, right? And here suppose I choose lag 1 and I press OK, and it is the arch test, right? And what is the null hypothesis? The null hypothesis is there is no arch effect. That is the null hypothesis. There is no arch effect. And here the observed R square and corresponding p-value is how much? 0. Meaning that it is less than 5%. It is p-value less than 5%, meaning that we can reject the null hypothesis, meaning that in this model there is arch effect. So what is happening in this model? There is clustering volatility and also arch effect. So meaning that we have all the right, we have all the ability, or we have all the validity to run a arch model, and that we shall be doing now. And today we shall be developing GARCH-M model.